All right, so we want to find and simplify the difference quotient. Do you remember what the difference quotient was? Sec y equal to what? It's a fraction. Do you remember how the difference quotient went? You said f of x plus 3, but I think you meant to say h. Yeah, so we want to find and simplify the difference quotient for the function y equal to x squared plus 3x. All right, so break it up into pieces. First, we want to find f of x plus h. Remember, that just means we take x plus h and place it wherever we see an x. So what would this one be? Exactly. All right, and we should expand this. What is x plus h squared expanded? Yeah. hmm And then for the second one, all we have to do is just distribute the 3. All right, we go so far? Okay. So we found what f of x plus h is. Now let's just plug it in here. All right. And we have minus f of x. F of x is x squared plus 3x, all divided by h. Don't forget that when you write the minus f of x part, you have to put f of x in parentheses. And you're going to have to distribute that minus. So we get x squared plus 2xh plus h squared plus 3x, 3h minus x squared minus 3x. Now we can cancel stuff out and combine like terms. We have x squared and minus x squared. They cancel each other out. We have 3x and minus 3x. If your last two terms, or if your f of x terms do not cancel out, you did something wrong. and more times than not, you didn't distribute your negative correctly. So this f of x part should always cancel out when we do this. All right, so after we get rid of those, we're left with 2xh plus h squared plus 3h, all divided by h. Each term in the numerator has at least one h, and we have one h in the denominator. So that means this one h in the denominator cancels out one h in each term. So this h is going to cancel out with this one of these, and this one. And we're left with 2x plus h plus 3. To clarify, I used y here and f of x here. It doesn't make a difference. It's still the same thing. It's going to work the exact same way. All right. All right. So we want to find and simplify the difference quotient for f of x equal to 3x minus 2. Y'all got this? First, find f of x plus h, and then plug it into the formula. So you would get 3x plus 3h, but don't forget about that minus 2. All right, and if we plug this into the difference quotient, we get 3x plus 3h minus 2 minus f of x is 3x minus 2 over h. All right, like I said before, the f of x part should always cancel out. And we're left with 3h over h, which equals 3. Right? Finding domain. We'll do one with rationals and one with radicals, and one with both. Go to the square root of 3x minus 5. And we want to find the domain. Remember, to find domain, we need to find where the function does not exist, right? For square roots, where does the function not exist? What can we not have with square roots? We're allowed to have 0. Yeah. we cannot have negative radicands. And if you don't remember, radicand is whatever's inside the radical. So we cannot have negative radicand. So that means the radicand has to be greater than or equal to 0. All right. So to find the domain, we're going to have to set the radicand greater than or equal to 0. And now we just have to solve this inequality. What do we do first to solve it? Start by adding 5. Okay. And we get x is greater than or equal to 5 over 3. So our domain is going to be everything greater than 5 over 3. These are all ways you can write the same thing. So this is interval notation, which you should have seen in Algebra 2. And this is set builder notation. I'm not sure if you guys got to that yet in trig, but that's where you would have seen it, I believe. And this is just the way you already know how to write it. Did you guys see set builder notation in trig? Okay. Wow. Either one of these answers would work, but this that makes sense. The procedure for solving this one. This is what you have to do for finding domain of all absolute, sorry, not absolute, square root functions. You just set the radicand greater than or equal to 0, and whatever you get, that's your domain. All right, now let's look at one that's irrational. All right, so when we have a rational function, what can we not have with rational functions? Zero where we cannot have 0 in the denominator. So that means that the denominator cannot equal 0. To find that, we have to set it equal to 0 and see what x values make it 0. How do we solve this one? There are two ways we can solve this one. What's your first way? We can factor it, yeah. And this factors down to x plus 2, x minus 2. Or for a case like this one where you have a quadratic, a two-term quadratic, you can actually just solve it out by adding 4 to both sides and then taking the square root. Right? You get the same thing. All right. So the denominator equals 0 when x is negative 2 and when x is positive 2. All right. So our domain is everything except for negative 2 and positive 2. How do you write that? All right. How do we write that in interval notation? The first one. Yeah. Negative infinity to 2. What else? There's more. Sorry. I switched this one from a bracket to a parentheses because we said it cannot equal negative 2. All right, so what's the rest? Yep. And yep. And to write this in set builder, it's x such that x is not equal to negative 2 and x is not equal to 2. All right, any questions? All right, so we have f of x is equal to 3x squared divided by the square root of 4x plus 1. What can we not have? And and 0 in the denominator. All right, so we can't have a negative radicand and we can't have 0 in the denominator. So that means for this one, the radicand has to be greater than 0. Before, when we did square roots, we did greater than or equal to 0. And then for rationals, we said it does not equal 0. So when we put it together, it's just going to be greater than 0. Does that make sense? All right. So we do it the same way we did when it was just the radical. This time we just set the radicand greater than 0. All right. And what do we get when we solve this? So if x is greater than negative 1/4, this one's in parentheses because it's not equal. This one, we have a combination of both. We have a radical and a rational. Radical, we cannot have negative numbers. Rational, we cannot have 0. So we have to set it greater than 0. All right. Are we good with this now? All right. We're adding two rationals and they do not have the same denominator. What do we have to do? In order to add or subtract rationals, what do we have to have? Yeah. In order to add or subtract rationals, we need common denominators. Is there anything we can multiply to x to get negative x plus 1? So first thing we need to do is figure out if the denominators are multiples of each other. By see if the denominators are multiple, I mean, is there anything we can multiply to x to get negative x plus 1? Or if there's anything you can multiply to negative x plus 1 to get x? There isn't, right? Second thing is see if you can factor. If we can factor these, we would factor it and then go back and see if there's anything we can multiply to each one to get them to be the same. And if that doesn't work, just multiply. If that doesn't work, then we multiply one denominator to the other. So we can't factor these. That means the only thing we can do is multiply one denominator to the other. So we multiply this side by x, top and bottom, and then this side by negative x plus 1, top and bottom. All right. Negative x plus 1 times 1 is negative x plus 1. And then 1 times x is x. In the denominator, we're left with x times negative x plus 1. Any questions on this step to this step? Right. Now that we have common denominators and we put them all under one fraction, we can simplify. We have negative x plus x, those cancel out, and we're left with 1 over x times negative x plus 1. So you can leave your answers like this, or you can multiply that x back in. That's fine, but you want to make sure that the fraction is fully simplified for your quiz. By fully simplified, I mean if you factor it out, nothing cancels out. All right, the second one. Is there anything we can multiply to x minus 2 to get x squared minus 4, or vice versa? Hmm? X, yeah. We can multiply x plus 2 to this one to get x squared minus 4. We know that because if we were to factor out this one, we would get x minus 2, and x plus 2, right? So the only thing this fraction is missing is x plus 2. All right. So we kind of took care of step 1 and 2 at the same time. Any questions on that before we move on? All right. Can we factor the numerator to get what? All right. So this is an example of the one I was talking about. You can either leave it like this or you can rewrite it like that because we see that nothing cancels out when we factor it. So if nothing cancels out when you factor it, you're allowed to leave it like this. But if something does cancel out when you factor it, and if you leave it like this, you wouldn't get full credit for it. Make sense? So you get an answer like this, factor it out to make sure it doesn't simplify anymore. All right. We have x squared times y squared minus 16 divided by xy plus 4. And we want to simplify this. Any ideas? What if we had x squared minus 16? Can you factor that to get what? So why would x squared y squared minus 16 be any different? I guess it wouldn't either. All right, so as long as they're both being squared, you're allowed to treat it as if it was just one thing being squared. It's going to work the exact same way. Does that make sense? One of these should be plus. All right, so this simplifies down to what? Yeah, all right. Don't get thrown off just because you see two variables in here. As long as they're being multiplied and they're both being squared, it's going to work the exact same way as it would if it was just one variable squared. All right, we have 16x to the fourth times y plus 8xy cubed divided by 4x cubed y to the fourth. And I want to simplify this. Ideas. When you learned about factoring, what was the first step? Look for what? Yeah. Look for GCF. In the numerator, do we have a GCF? Yeah, what is it? Yep. And if we take out an 8xy, what's left? All right. Can we simplify anything else? What do you mean? The bottom's already factored. Everything's being multiplied, so it's already factored. But I feel like you're on the right track. So everything in the numerator is being multiplied, right? This 8xy is being multiplied to this group, and everything in the denominator is being multiplied. So when everything's being multiplied, what are we allowed to do? We are allowed to, yes, we're allowed to divide and simplify. So we can divide 8 by 4. What do we get? Yeah. We can divide x by x cubed. What do we get? Divide y by y fourth. Can we simplify anything else? The answer is no, unless we break it into two fractions, which we do not want to do. So this is fully simplified. You get when you divide. Start with the constant. It would be -3. All right, now look at the x's. X squared where? And the y's? That's it.